Good afternoon, Marika.
Hi, sir. Afternoon.
All right. We're gonna go through the 2008 Unit 1 now. All right. Yesterday we went through the Unit 2. And what I'm gonna give you for mock exam is I'm gonna change it up a little bit. Remember I said that I was gonna give you a more recent paper to do? No, I don't want you to do that. I'm gonna ask you to do 2009 Unit 1 and 2009 Unit 2. Then I'll send you the solution for those, and next week we're gonna go through 2010 together. All right. So that's
Which
changing
solution,
up a
sir?
bit.
Which
So
year?
I want you to do 2009 for mock exam, Unit 1 and Unit 2. All right. This document that I upload have all of them. So let's go to 2009 and the Unit 1 and 2009 for Unit 2. All right.
Okay.
All right. So now we're gonna go through 2008. So let's do it. So 2008 Unit 1, 2.5 hours. I don't know why the paper 2 was on the 30th, but that's weird. All right. So this one says now, and I'm happy it start with this. It says determine the values of the real number h for which the roots of the quadratic equation are real. And notice in the mock exam I gave you, you left out a question like this blank. Now notice these are very popular in CAPE. Determine the values of some real number such that the roots of the quadratic equation is real. All right, so let's write that out now. What does real mean, Marika? What do they mean when they say real? The roots are real. Can you hear me?
Yes, sir. Can you repeat what you're saying?
What do they mean when they say the word real? When they say the roots are
Numbers that are not rational.
when you're talking about roots, what do we mean when we say roots are real? What does roots mean? What are roots? What are roots, Marika?
I'm not sure of like an exact definition.
No, this is roots, Marika. When you draw your graph, your quadratic graph, roots are just the x values where it cuts the y-axis, the x-axis. These x-intercepts are known as roots. And we talked about it already. There are 3 types. You have real and different. You have real and equal, and you have when they're imaginary. When you have a quadratic, Marika, and it's completely above the y-axis, we say they're imaginary. You remember who did this discriminant
Yes, sir.
worksheet?
I remember.
Imaginary. All right, that's all they're talking about. All right, so you can't forget it, review it. So now, Marika, the roots are real when the discriminant b squared minus 4ac is greater than or equal to 0. This is when the roots are real. When b squared minus 4ac is greater than or equal to 0. This will be when the roots are real. So in this case, b is minus 2h. So you're going to write minus 2h squared.
So is that the formula for AC? Yeah.
Yes,
right.
b squared minus 4ac. That's the formula for discriminant. All right? You have to review it. So it's b squared minus 4 times a times c. 4 times 4 times c. C is 8 minus h. So that is 8 minus h. And this is what? Greater than or equal to 0. Then we're just going to solve for h. Square both sides. Well, not square both sides. Square the 2 term to get 4h squared. Minus 4 times 4 is 16. Then 16 times 8 is, I think that's 256. Let me do it this way. 8 times 4 is 32. 32 times 4 is, all right, let me just get out the calculator. Minus 4 times 4 times 8, that's minus 128. So this becomes minus 128, and then minus 4 times 4 is 16, times minus h, that become plus 16h. And this is greater than or equal to 0. Yeah? So now we end up with a quadratic, Marika. What we can do is divide the quadratic by 4. Just to make it easier on us, we divide it by 4. What we're left back with is h squared minus, well, let's do this part first. H squared plus 16h over 4 is 4h. Then 128 divided by 4 is minus 4 into this would be, I think that's 32. Greater than or equal to 0. That's 32, right? That's 32?
Negative 120.
8 divided by 4, that's 32? Yeah, that's 32. All right. So now we just need to look at this and see if we can factor it. Which two number of times then we get 32 and add them, we get 4. Let me see. 8 and 4 should work. So it's going to be h, close that bracket, greater than or equal to 0. It's going to be 8 and 4. This is saying signs are different. The bigger one is positive. So plus here, minus here. So what that means is we really have a quadratic now, Marika. We have a quadratic. And this is a quadratic. We have the h-axis. The two h values we have is 4 and a minus 8. All right. If you were to set them here equal 0, you have 4 and you have minus 8. All right. And this is greater than or equal to 0. What does that mean? What that means, Marika, is the solution that we want is right here. We want above. We want up here. So since we want up here now, the solution region is going to be h is less than or equal to minus 8, or h is greater than 4. Greater than or equal to 4, and this is the answer. All right, that's the range of values h can be. H can either be less than minus 8, or h can be greater than or equal to 4. So discriminant is very popular. You have to remember it. All right, it starts from this formula: b squared minus 4ac greater than or equal to 0. All right, Marika, have to remember it. Cool with that?
Yes, sir.
All right, so you have to remember it. All right. So that would be the range of values where the roots are real. All right, h can be less than or equal to minus 8, or as we said, h can be greater than or equal to 4. Nice. All right. All right. Now the next one says the root of the cubic equation x cubed minus 15x squared plus px minus 105 equals 0. And it says these roots are 5 minus k, 5 minus k, 5, and 5 plus k. And it says find the value of the constants p and q. No worries, they give us the 3 roots, right? So you can do it one of 3 ways. You can either use factor theorem, or which other way can you use? Which other way can you
4,
use?
sir.
For this question, part 2. You can use sum and product of roots. You can use factor theorem, All right, those are the two ways you can do this one. So anyways here, so just for practice, we're gonna do it both ways, all right? So let's write out this cubic now. So we have this cubic x cube minus, what was that again? 15x squared x cubed minus 15x squared. All right. This is plus px minus 105 plus px minus 105 equal to 0. All right, nice. And they tell you that again, let me see what they say are the roots. They tell us that the roots are 5 minus k, 5 and 5 plus k. Those are the roots. So let's write it in words. The roots are 5, 5 minus k and 5 plus k. 5 plus k. All right, so which way you want us to do it first? All right, let's use sums and product. I want to do it that way first. Sums and products method. All right. Now, remember the formula for we find the sum. We said that the sum of the roots of a cubic, the sum is what? Minus b over a, right? That's how we find sum of roots, right? Minus b over a. So it's going to be minus 15, which is 15 over 1. And 15 over 1 is 15, right? Right? Cool with that? Are you hearing me? Can you hear me, Marika?
Yes, sir.
All right, so the sum is 15, and 15 is equal to the 5 plus the 5 minus k plus the 5 plus k. All right, so 15 is equal to 5 plus 5 minus k plus 5 plus k, which is true because we end up get two sides equal 15. So no, say that good so far. The next thing we know that is the product of the sum, P2, is equal to C over A, C over A. In this case, C over A is going to be P, it's going to be P over 1. All right, and P over 1 is going to give us, P over 1 is going to give us, see it there now, 5 times 5 minus K plus 5 times in bracket 5 plus K, close that bracket, plus 5 minus K times in the next bracket 5 plus K. All right, this is going to give us product of 2. All right, so this right here is telling us then that P is equal to, all I have to do is expand this. 5 times 5 is 25. Then this becomes 5 minus K, so that's 25 minus 5K. Cool. Then I have 5 times 5 is another 25. And then we have 5 times 5K, that's another 5K, but this time positive. And then 5 minus K times 5 plus K is a difference of 2 square. So we end up get 25 minus K square. What does that do for our calculations? The 25, and the 25 is 75. So end up get P is equal to 75, and then the minus 5K and the 5K cancel, so we get 75 minus K squared is P. All right, that's what we get, 75, because this minus 5K and this plus 5K cancel. So end up get 75 is equal to 75 minus K squared. That's giving us P. All right. Now we have one more thing to do now, Marika. The last thing that we have to do now is we we know that the product of three roots, P3, is equal to minus D over A. In this case, it's going to be minus 105 over 1, which is just 105. And so 105 is going to equal to the product of the three roots. And the product of the three roots is 5 times in bracket 5 minus k times in bracket 5 plus k. That's going to be the product of the three roots. 5 minus k times 5 plus k times 5. That's going to be the product of the three roots. So what we're going to end up getting is P3, which is equal to 105. That is equal to, all I have to do now is multiply them three roots here, Marika. This is easy to multiply. This works out to be 5 times in bracket 5 minus k times 5 plus k. That's 25 minus k squared. That's 25 minus k squared. Expanding in this now, this 5, we get 5 times 25 is 125. And then 5 times minus 5 minus k squared give me minus 5k squared. And this is 105. So see then now, Marika, we have two equations. So now we can easily solve for P and K. We have 105 equal 125 minus 5k squared, and we have P equals 75 minus k squared. So look at this now. From this equation, we can find k. Let's find the k first. We're going to bring over the 125 to get 105 minus 125. 105 minus 125 is negative 20. So negative 20 equal to minus 5k squared. Do you follow how I get the negative 20? Do you follow, Marika?
Yes, sir.
Good. And then we just divide both sides by negative 5. Divide both sides by negative 5. So what we end up get is minus 20 over 5 is 4. So 4 equal k squared. And if 4 equal k squared, then we know k must be 2. All right, nice. K equal 2. Since k is equal to 2, Marika, we can plug 2 in here. And so that means P is going to be equal to 75 minus k squared, which is 75 minus 2 squared, which is 75 minus 4, which is 71. So that is P, 71. Cool with that? So those are your answers. K equal 2 and P equal 71. Cool with that, Marika?
Yes, sir.
All right, nice. So that's it. K equal 2 and P equal 71. Nice. Yeah, man. All right. So that's it. Easy question. So K equal 2 and P equal 71. All right. And I'm suspecting that, Marika, I just strongly believe that these are the questions that are going to come back. I just really believe that 6 if you nobody not practice them here, and them here will come back. I'm telling you. So to get P equal 2, K equal 71. Nice. All right. Now let's look at this now. That's 8 and 7 marks already. I want to do nothing yet. This question now, Marika, is a graph. All right. Yes, graph is on the, well, modulus functions is on the syllabus. Remember, so graph can come. And it says copy the table below and complete by inserting the values for the function. So when x equal minus 3, what will happen? When x equal minus 3 in f of x, minus 3 plus 2 is minus 1. Modulus of minus 1 is 1. When x is minus 2, Marika, minus 2 plus 2 is 0. So f of x will be 0. That's an easy mark. When x is 0, we know f of x will be 2. When x is 2, 2 plus 2 is 4. F of x will be 4. When x is 3, 3 plus 2 is 5. Easy mark A, 5. 5 plus 2 is 7. Nice. We got 2 out of 4 mark already. Now let's look at down here. G of x is x minus 1. Modulus of that then times 2. When you put 1 right here, 1 minus 1 is of course 0, and 2 oh, this is minus 1, not 1, my apologies. Minus 1 is minus 2. Modulus of minus 2 is 2. 2 times 2 is 4. Do you understand how I put 4 right here, Marika? Make
Yes, sir.
sense? Good. Now, when it's 1 now, 1 minus 1 is 0. When it's 3, 3 minus 1 is
So that's 4.
4. Good, good. So what got here so now?
4 minus 1 is 3. 3, 2, 6.
6. Good. And then here so?
5 minus 1 is 4. 4, 2 is 8.
8. Good. All right, nice. So we're going to sketch these graphs now. It's using a scale of this, draw them on the same graph. Of course, we have the luxury of actually just going to graph app. We don't need to be sketching a graph. So I'm going to open the graph app right now. All right, going to open the graph app, GSP5, and we have the luxury to make it real pretty. A matter of fact, we don't even need to sketch it. All I need to do is type in this function. So that's what we're going to do. And we're going to choose the domain between -3 and 5. So let's do that. GSP5. We're going to graph. We're going to.
So once you choose the domain, it can just show you what points are going to lie on it.
Yes, once you click on the domain that you want to sketch the graph for, it will give you exactly where you want it. So let me see if we can do that. Plot new function. Does it allow me to? Oh, but it doesn't show me the domain. Shoot. All right, let's do it like a test then. Let's do it like a test. All right, if it were a test, we'd have to, of course, put the domain. We know we need from -3 to 5. So only gonna plot from -3 to 5. Oh, I'm too lazy to do this. Let's just put it in. Modulus of x plus 2, that's f of x. Too lazy to put that in. All right. Modulus of x plus 2. Oh, it actually can't plot the modulus in this one. All right. This can't plot it. I have another graph up. So let's try that one. This one won't be able to do it. I don't know what's wrong. My computer is just itching a little bit. It's frozen. So let's just go a little slow. Do I have too many programs open? Let me close some stuff. Let me close that. Let me close this. All right, let's see if that works. All right, it's moving a little better now. So we can actually plot the graph now. So I've clicked on graph. Can you see the graph?
Sir.
All right, so we're gonna just insert the function. We're plotting y equal to the modulus of x plus 2. And this is in the domain from, I'm just putting a start and end point, and we want it from -3 to 5, I believe. It doesn't know what the modulus mean. That's crazy. How do they plot modulus? Wow. All right, I know what I'm gonna do. Oh boy, we're just gonna have to plot the points then. That's what I didn't want to do, because it would have taken 10 minutes. All right, we're just gonna plot the points then. All right, so might as well I'd use the other app then, because the other one is more better to use for plotting. So we're gonna have to just plot. I really thought I could have put in the modulus and that's it, but no, we can't. So let's plot the points then. So f of x, you have -3, 1. So we're gonna plot these points, plot points. We have -3, 1. That's 1 point. The next point was -2, 0, -2, 0. Plot that one. The next point was -1, 1. Let's plot that point. -1, then 1. Then the next point was 0, 2, 0, 2. Then we had 1, 3. Then we had 2, 4. Then we had 3, 5. Then we had 3, 5, then 4, 6, then 5, 7. 3, 5, then 4, 6, then 5, 7. All right, so that's it. Those are the points that we have. All right, since these are the points that we have, this is now f of x being, this is f of x being the modulus of x plus 2. All right, so this right here is f of x being the modulus of x plus 2, or yeah, the modulus of x plus 2 is. All right, so we're just gonna label it that way. This is f of x equal the modulus of x plus 2. All right, nice. So that's f of x. All right, that's f of x. So that's f of x. Now let's plot our g of x. G of x, the points were -3, 8. All right, -3, 8. Just gonna use a pencil and do it. -3, 8 is, no, that wouldn't look clear. -3, 8 is here. Sorry, then we have -2, 6. Then we have -1, 4. Then we have 0, 2. Then we have 1, 4. Then we have 2, 6. Let me make sure I go back that I'm doing the right thing. 2, 6. We have 1 and 0. Did I plot 1 and 0? Oh no, I didn't plot 1 and 0. So let me 1 and 0, 1 and 0 right here. Then we have 2 to 2. Then we have 3 to 4. Then we have 3 to 4. Then we have this one right here, 4 to 6, which is right here. Then we have 5 to 8. All right, that's what we have. This is this right here. So that we just plot is our g of x, 5 to 8. So we're done now. So now we'll plot the graph. We can say, yeah, man, we're all right. Let's just connect them. And from here, this is it. All right, so now we just label it and put that this is our g of x equal to, this is the modulus, g of x equal to the modulus of, actually 2 times the modulus of x minus 1. All right, now Marika, it says using your graph, Find the values of x for which f of x equals g of x. So look at this graph and tell me where f of x equals g of x. Tell me the values. Where does f of x equal g of x?
Oh, for each of them?
Yes, where does these two graphs equal each other? Where does f of x equal g of x?
2.
2. When x equal 2, this is 2. They don't equal when x equal 2.
When x is equal to 2, 3, 4.
4, very good. When x equal 4, this is one point of intersection. And another point of intersection is right here.
When
So
y is equal to 2.
when x is 0, they don't care about y. When x is 0. All right, good, yes. So we can tell them that right here. So using our graph, they intersect when x equals 0 and when x equals 4. Now, Marika, look at this. You didn't even need to use the graph. You could go back in the table and look in the table when the two of them have the same y value. So you notice them have the same y value here. So 2, 2, that at one as 0. Whereas them have the same y value? 6, 6, which is the 4. So those would be the two x value when them intersect, all right?
Oh, you see.
Yeah, cool?
Yes, sir.
Nice, nice, all right? Now we'll move on to question 2. Now question 2, Marika, it says without using a calculator or table, evaluate 27 to the 10th plus 9 to the 10 over 27 to the 4 plus 9 to the 11 all square rooted. That look nice, don't? That look nice?
Yes, sir.
All right, so let's take on that one now. It says evaluate. All right, give me a second. Let me plug in this PC. All right, so let's continue now. So it says without using our calculator, we need to evaluate the square root of this thing right there. Look like it's going to be a little bit of fun. So we need to, without using a calculator, Marika. So they're saying we should be able to do this easily. We want the square root of 27 to the 10th power plus, let me see what that is, 9 to the 10th power, 9 to the 10th power divided by, let's see what that is again, 27 to the 4 plus 9 to the 11. 27 to the 4 plus 9 to the 11. No, don't worry, Marika. These are easy questions. It looks spicy, but it's not spicy at all. So first thing is, let's put back our square root. All right.
Would you want to change it?
Very good. We need to change it to what?
For the 27 to the 10, 9 times 3?
No. Well, 9 times 3. Almost there. Say it a little better. 9 times 3. What do you mean 9 times 3?
Because 27, you change it like the factor.
All right.
So 9 times 3, and then for the bottom one.
No, we don't say 9 times 3. Don't say 9 times 3. We're changing it. We're using laws of indices and rewrite 27 then as 3 cube. Make more sense? 3 cube. Okay. Yeah, 3 cube to the 10th. Plus, you can change 9 to what?
You change 9 to 3 squared.
3 square. Yeah, then it's not easy now. Yeah, 3 square to the 10th. Exactly. Change it to 3 square to the 10th. All right. Nice. And we can do the same. Make everything in terms of base 3. So this is 3 cube to the 4 plus this one is now 3 square to the 11. Nice. All right. So now all I have to do is just simplify this now. All right. So this works out now to be the square root of, you see that part now, Marika? 3 to the, this 3 cubed to the 10th is just 3 to the 30 plus this 3 squared to the 10 is just 3 to the 20, right?
Yes, sir.
Over, this is now 3 to the 12, 3 times
and
4.
3 to the 21.
21.
22.
3 to the 22. Don't give it away. 3 to the 22. Good. Now, what I realize is that you see in that numerator right there, I can factor out 3 to the 20, no? Can we factor 3 to the 20 in the numerator?
Yes, sir. So
And
you
then we're left back with 3 to the
3 to the 10.
10. Very good. Plus 1, right? Plus 1, right?
Yes, sir.
Divided by, what can we factor out of the denominator?
3 to the 10, I suppose.
3 to the 12. Factor out 3 to the 12. Because that's the highest between the two of them. Factor out 3 to the 12. And then we're
Would
left
it be the
back with
highest or would it be the lowest?
the lowest to factor out, 3 to the 12. Right? Then we're left back with 1 plus 3 to the 10, right?
Yes, sir.
Now look at that, Marika. 3 to the 10 plus 1 and 1 plus 3 to the 10. Aren't these two the same?
Yes, sir.
So this cancel, right?
Yes.
Right? So work out so easy because now we're just finding the square root of, this works out to be 3 to the 20 over 3 to the 12. But can't we say 3 to the 20 over 3 to the 12 is 3 to the 20 minus 12? Can't we say that?
Yes.
And that is just 3 to the 8. This is now just 3 to the 8 being square rooted, right?
Yes, sir.
But then if you're square rooting 3 to the 8, isn't that just 3 to the 8 being raised to the half power?
Also, it'd be 3.
So this is
3
just
to the
what?
4.
3 to the 4, and 3 to the 4 is 81, right? 81, right? Easy.
Yes, sir.
You saw this question soft, don't? Right? Soft?
Yes.
Soft. So if you get a question like this, you know to tackle it already. They're always going to make sure you can either use logs or indices. Look out for those type of questions. Easy. So that's just 81. All right. So just to actually do it on the calculator now, because it's always good when you verify your thing with the calculator. Square root of 27 raised to the 10th power plus 9 raised to the 10th power divided by, this is 27 raised to the 4th power plus, this is 9 raised to the 11th power, 81. Easy, you see it?
Yes, sir.
Cool. So we'll get 8 marks without a worry. Now let's look at the next one right there. All right. Now I don't like indices questions because they're too easy, but I love log questions because these usually make you think a little bit more. It says prove that the log to base n of m is log 10 over m over log 10 of n. Now Marika, if you notice in the search logs and indices notes, I put the proof for everything. I said you don't need to know the proof. Well, cancel that thought. All right, I was actually telling you rubbish. I didn't look back in the long time paper. You actually can get it as a question. So I did put the proof in the notes and we didn't go through the proof then, but still gonna go through one here so you can actually go back through the proof, see what they make sense. So look at this now. Log n of m, just to write it down. Log n of m, they said we should prove that log n of m is log to base 10 of m over log to base 10 of n. So this is the change of base rule that we're going to prove. All right. Now, in order to do this proof, Marika, it's a little bit, I'm going to prove it a little bit different than the ordinary, all right? I like to prove it the easy way. So this is the easy way now. Look at this. Let's look at this right here on the right-hand side. If I were to I'm going to use the letter X because X keep coming to my mind. So let X be equal to, no, I don't like how X look again. I'm going to use A. Let A be equal to log to base 10 of M, right? If A is log to base 10 of M, right, then what do we know, Marika? By definition of logarithm, that implies that 10 to the A equal M, right? You follow that so far? This makes sense, right? This is the definition of logarithm. For example, if I tell you that the log to base 10 of 100 equal 2, doesn't that mean that 10 squared equal 100? Is this the definition I'm writing down? Right? You remember
Yes,
the
sir.
definition? Yes, so we just wrote down definition. All right, so we wrote down the definition and we're gonna do the same for this one. So we're gonna call the next one B. Let B be equal to log to base 10 of N. And so that would mean what? That means 10 to the B equal N, right?
Yes, sir.
Nice. All right, so this is what we do now. All right, Marika, look at this now. So now we're gonna do the proof by starting with our left-hand side. So our left-hand side is equal to log to base N of M. But log to base N of M, Marika, that is just log to base N of, remember what is M? M is 10 to the A. M is 10 to the A. Yeah, you cool with that?
Yes, sir.
Right?
Yes,
Then
sir.
now we can use the power law and bring down the power and write it as A log base N of 10, right?
Yes,
Right?
sir.
But now, Marika, remember another law I told you, that log of any base of a number n is equal to 1 over the log of the number turned to the base n of b. I told you this law, right? It's in the third notes, the third plus indices notes. So applying that here, this becomes a times, in bracket, this is gonna then become 1 over log to base 10 of n, right? Right, Marika?
Yes.
Which works out equal to be a over log to base 10 of n, right? A log base 10 of n, right, Marika?
Yes, sir.
But then what is A? A was log to base 10 of M. Oh, beautiful, though. A was log to base 10 of M. Isn't that what we call A up there?
Yes.
So see the proof? Easy, though. This easy, though.
Yes, sir.
Easy, all right? Soft, easy. Log proofs are so easy, soft. So you can write, say, hence, this is equal to your right-hand side. All right, nice. So you can tell them to this soft, man, soft. You can tell them, write it on the paper. Tell them soft, right? Tell them Marika Calvin says this was soft. Yeah, man, put it on the paper. All right. Now it says Marika, hence, calculate the exact value of y given that y is this. So pretty much what I'm gonna say is don't use a calculator again. So let us write out this now. And it said hence, so we're gonna use this knowledge up here. So let's write out what y is. All right, so writing out what y is, it says y is equal to log to base 2 of 3 close that bracket, multiplied by log to base 2 of, not base 2, log to base 3 of 4, multiplied by log to base 4 of 5, multiplied by, I will continue doing this till we reach log to base 31 of 32. I will multiply all of these. This is what we need to do, and we need to work out what y is. So look back at the question. See there? This is what they say we need to do. So prove this well easy, Marika. This well easy, you know, well easy. Look at this. It said hence. See hence here? Your n and your m is log to base 10 of m over log to base 10 of n. So hence me and Marika will change log to base 2. So I rewrite this as log to base 10 of m. M is 3. So it's log 3 over log to base 10 of n, which is pretty much log to base 10 of 2. Close that bracket. That is then being multiplied by, we change this now to log to base 10 of 4 divided by log to base 10 of 3. Oh gosh, man, this is easy. We're going to change log to base 4 of 5 to log to base 10 of 5 divided by log to base 10 of 4. Nice. And we're going to continue and continue. Dum, 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 dum. Continue until we reach log to base 10 of 32 divided by log to base 10 of 31. All right, this is what we end up gonna get. Now, Marika, look at what happened right here. As you can see, this would cancel when you're multiplying. This cancel this cancel. The log base 4 would cancel this. So that means that the 5 would cancel the 5 somewhere here. The 31 would cancel the 31 somewhere right here. Right? You see how them cancel? Because when you multiply them, they would cancel, right?
Yes, sir.
That makes sense? So what we end up left back with is that y is going to end up work out to be, all of them they cancel left in the numerator to be log to base 10 of 32, log to base 10 of 32 divided by log to base 10 of 2. Log to base 10 of 32, which is just log 32 over log 2. See there now? Log 32 over log 2, log 32 divided by the log of 2. Oh, I don't close the log bracket. They're so strict. 5. So that's the answer. The answer works out to just be 5. You saw that easy, Marika? Why just 5, you know? Math's nice, though. Don't, Marika? That's nice.
Sometimes.
Yeah, this not, imagine your work. You start with one question will look complex. Imagine you say, Mommy, look at this, and you show your mommy this. And you show your mommy said that just equals 5. You know, your mom would be impressed with this and she said, whoa. And worse, when you take out your calculator and show her, and when she multiply out that you get 5, you don't think this is impressive. Yeah, that's impressive, right?
Yes, sir.
Nice. So what you can do is take out your calculator. Let me show you what I mean. You can take out your calculator. I'm not going to do it because it's going to take too much time. But you can do this. Put in all of it. Log to base 2 of 3. Close the bracket. Then you multiply it by log to base 3 of 4. Close the bracket. And keep on multiplying them. Go straight out till they reach the last one. Just try it. And I guarantee you're going to get the 5. But we can't bother type out all of this right now. That's crazy. All right, because that's typing out about 30 different logs in a calculator. That's too much. So now let's look at part C. Part C says, prove by mathematical induction that Fn, which is 7 to the n minus 1, is divisible by 6. All right. So it says Fn which is equal to 7 to the n minus 1. We need to show that it is divisible by 6. This is fn. Since they call the function fn, we don't need to select n equal 1. We can say testing if fn of 1 is true. So step 1, we need to check to see if f of 1 is true. If this is divisible by 6. So for f1, Marika, realize that f of 1 would be equal to 7 to the 1, which is 7 minus 1, and that equals 6. But 6 is divisible by 6 because 6 can be written as 6 times 1. So therefore, n equal 1 is true. All right, n equal 1 is true. I know you love these induction questions, so let us hurry up and blow through this because I see you shell this off on the mock exam. So let's hurry up and finish off this step. So now next would be for f of k is true. Assume f of k is true. This is for f of k, right? Where we let n equal k. What we end up getting is f of k is 7 to the k minus 1. And we can call this equal to 6q, where q is an integer. So I have to write where q is an element of z. Yeah, where q is an integer. And we assume that fk is true. Assume f of k is true. All right, nice. So step 3 now is for f. Step 3 is for when n equal k plus 1. So for n equal k plus 1. So for n equal k plus 1, right? That's what we're going to do now. Let's do it over here. So we can write f of k plus 1. F of k plus 1 is equal to, this is going to be 7 to the k plus 1. 7 to the k plus 1. Yeah. Minus 1. Yeah, man. 7 to the k plus 1 minus 1. Now, what we can end up doing now is break up 7 to the k plus 1 as 7 times 7 to the k minus 1. But then we know that from this step right here, 7 to the k minus 1 is 6q, and so 7k would be 6q plus 1. So we can end up writing that this is 7 times in bracket 6q. Don't use my q, Marika, only I use the letter q. Use the only letter, use m. M for Marika, all right, minus 1. So we expand and we get 42q. And then 7 times 1 is 7 minus 1. So we end up get 42q minus 42q plus 6. And then we can factor out 6. So now we can factor out 6 and end up right that this is equal to 6 times in bracket 7q plus 1, which is actually 6 times some number m for Marika, where can write where m is 6 7q plus 1. All right, nice. So therefore, n equal k plus 1 is true. Let's say thus. Thus n equal k plus 1 is true. Then now we can write our conclusion and say thus, by principles of mathematical induction, f of n, which is equal to 7 to the n minus 1, is true for all, natural numbers. All right, so that's it. Easy. I know you shelled on this one. I have no problem. Right, Marika? I know this is your favorite induction, right? Right, Marika?
Yes, sir.
All right, good. All right, now finish with module 1. So module 1 was good?
Yes.
Right.
I think I need to, for module 1 is maybe laws, no, not laws of indices, logs.
logs.
Yeah.
All
For
right,
me.
okay, all right, good. So brush up on the logs then and get there. All right, good. All right, nice. Now module 2,